Yeah, my name is Ivana Ersø, and I work here at the Technical University of Denmark. So, and you have all seen the place. So I have not done so much to introduce DTU as a whole. I will tell you something about the CDIO concepts that we have worked with in the biological chemistry compulsory course here at DTU, and we have focused especially on collaboration and technical communications between the groups. And Lars, who is sitting here, is one of the co-authors of this work, so he can also, in the breaks, answer questions about the work we have done with the students. Biological chemistry is a compulsory course at the second semester, and the students follow the chemistry food analysis or biotechnology bachelor engineering study program. It consists of a theoretical part, a laboratory part, and also a project part. And every semester we have between 24 and 50 students. I have looked a little bit into the students' background some years ago when I made a survey of the student, and there are a few who have no background in biology, and it's because they have done, maybe one was a taxi driver and did some math and physics and chemistry that allows you to start here at the university, but biology is not one of the courses that are required. And then we have students that has biology at the C level in high school, about half, and about half has the A level. And biological chemistry is a little bit overlapping the A level at high school, which means that half of the student has quite a good background, whereas the other half have not as good a background. So we have to take everybody into consideration and be good at explaining the course. And of course, when you have some that are really good and some that are not so good, you have this problem with that you might oversee that some is not following the course as well as they should. Their interests also influence and their future plans, and about half of them think they will continue in the area of biotechnology, which means they are more interested in the topic, whereas 1/3 wants to continue to master levels, and maybe they have not found out yet, but we know that about 1/3 they continues to the master level, so they are considered to be good students. And then we have, because it's a second semester course, about 10–15% that don't even know if they are at the right education. So these are the kind of group of students. Our motivation of changing the course was, of course, because we had to do it, because the CDIO has to be part of the bachelor education here. And we also struggle with a bad integration between the theoretical part of the course, where they have normal lectures with a book where it's very fixed what they have to learn every lesson they have. And then we have this laboratory part, which was new teachers and also was not linked to the theoretical part. And then again they had a project which was a third topic. So we wanted to see if we could integrate it better. The laboratory part, which is what I am focusing on, laboratory project part of this presentation, was also what we call cookbook principle, which means they get a protocol where they can work from like a cookbook, which means that they don't necessarily have to think so much, and are not necessary for them also to understand the background of what they're actually doing. The advantage with the way the work in the laboratory was before was that it was very clear to the student what is the minimum requirements. And for the teachers who have done it in several years, it was also kind of routine work for the teachers, which means they need to prepare less. The disadvantage is that the students, they came unprepared to the lab, and they gained little understanding of the exercises and workflow in the laboratory. The project part was a theoretical essay, and it was dealing with a completely different topic. So we think that they gain very little, what do you call it, a transfer from the laboratory part to the theoretical part and the other way around. When we implemented the CDIO learning concept as part of the implementing of CDIO learning concepts in general, we aim to also create a better understanding between the theoretical and practical aspects of the course. And we aim to also improve the engagement of the students in the laboratory part. Lots of the time they just came unprepared, what are we doing today? And it was not the most successful way of teaching. And we wanted also the students to commit seriously to this preparation and work related to keeping laboratory journals and reporting results. Also because we think that the habits that you learn very early in your study hopefully are some good habits that you will take with you next time where you have to do a project where it's really serious if you don't really keep good laboratory journals and so on. The aim of this work I'm presenting is to describe how changes were done in the training and project-based learning, which was implemented in order to train the students in making the study design. We want them still to learn the basic laboratory skills. We want them to be able to handle data and to communicate technical communication and collaboration, and also to improve presentation of data. So the process was the theoretical project which we had and the laboratory project was integrated. We still have the theoretical learning where they have lectures and a book that they follow. So it was 2 out of 3 parts that we integrated. This new project was designed to include the practical execution of techniques and biological experiment, which was taught in the theoretical part of the course. So hopefully they would get a better transfer of knowledge between the theoretical and now this integrated project laboratory part. And we wanted to give the students an opportunity to implement and operate these obtained skills from the theoretical part and their knowledge. And the way the students work, the students now work in group. They have a main topic which the whole class have, and then they have under this topic, each group has their own subtopic. So this was new to the students, and then because we have also this practical issue of how to run the laboratory, so they make the same exercise in the laboratory, but they have their own kind of meat we work with, that they work with in the lab, and so they have kind of their own samples, but they all do the same experiments. So they collect these samples, and the criteria for collecting the samples they have defined in class. The samples are subjected to the same set of experiments in all groups, as I said, and the results of they are shared between the groups. And that means they have a subtopic, which means, for example, they have to collect the background data of all the meat samples they have collected. They don't have to report their own 2 samples, but one group is responsible and have to collect for the whole class. And this was to strengthen their ability to work, to do teamwork and collaborate between the groups. So the groups, they present their own subtopic for the entire class before we have lab experiments the first time, and then again they do an oral presentation in the end of the course where they present a poster. So they have 2 presentations, one where they do not have so much knowledge and they have to do as best as they can, and then in the end where they actually have some results and should have some more background knowledge. And if we look at how it's divided, we have 8 days where they work, and you can see here the first day we do a kind of, the main topic is presented to them, and we do it in a way that they get some information, and then they have an idea of the main topic. And then we present also the subtopics, and they are divided into groups. And then the next time, at day 2, they have a week to find out something about their topics that they have to present. And they're really scared in the beginning, but we know nothing. How can we do this? So you just have to do your best, and you are equal. All of you know nothing. And usually they are able to present. And then one group has a task, because they have, after they have heard their presentations from all the subtopics, they have to work together in the entire class to find out how are we going to sample our meat samples, what shops and so on. And then they have afterwards 4 laboratory working days. It's half a day, but they have to do all the experiments where we give them a fixed protocol and they come with their samples. And then at day 7, they get some information about how to make a poster, and they exchange results between the groups, because this is really a difficult exercise for them that we have done a lot of work in order to make them take this serious about exchanging results. And then at the end, they present their poster in front of the entire class. We have a censor, so that it's an examination where they get a grade, and they are getting feedback from us in front of the entire class. The first day, where the main topic we have worked with is antimicrobial resistance in Danish and imported meat. And it could be any problem, but it's a problem that has a lot of awareness in the press, and they know about. So they get a general introduction, and then what we have done, and we have done a little bit differently, but several times we have given them a press release, so they can see this is some data we have done here at DTU, and we are sending it to the press, and they can see, read, find articles and so on. And this is at a level where they can read it and understand it, because it's made for journalists. And because they do not have any special background, it helps them that this is a topic that's of public interest. And meat food it's part of their daily life, so they know something about it without knowing. And then this press release is in a language where they can understand. So we get, I think, a pretty good discussion where they can come up with a lot of things that are something that we can work from and elaborate on and so on. The topics that they get are more related to their theoretical work. And that means one group has this with sample information, and this is some general thing about how do you sample, what do you need to be aware of and stuff like that. There's some general about bacteria, some resistant mechanisms they work from. One group has something about gene detection, and one group has about horizontal gene transfer. All some topics that they touch upon in the theoretical part. Then this agreement about the sampling strategy is also an important thing, because we would call it serve it for them in a way so that they get an idea of they have to decide what to do and what is the pitfalls in this and so on. So they have to decide, they know that they can only collect 2 samples per group, but then they have to decide how are we going to do this. When will is it Sunday or Monday we get the samples? What shops can we get them from? What information should be on the meat? Should it be, can we buy it in a butcher store with just wrapped in paper, or do we need to have some label on? And meat type, is it pork we analyze or so on? Because if they have 20 samples all in all, they cannot just look in all kinds of meat, because then they cannot compare. So they get an idea of what is it you have to be aware of. So we think that it makes them aware of responsibility towards the entire group, and awareness of the limitation in assembling, and they get a better understanding of the process, and they get a general discussion of study design, and it also creates ownership in this main topic. And then what we have found out that we need to be very strict about, because we want them to be prepared when they meet for these lab works they do, and they have to give in a flow sheet, and it has to be approved by the teacher, and they also have to do a laboratory journal, and that also needs to be given to the teacher before they leave at that exact day. So they have to give these two things, and it's mandatory. So they need approval. And why is that? We want them to avoid that they start without being prepared. We want them to be assured that they're aware of safety rules. We work with bacteria, it's very important. We want them to ensure that they know what they're doing, and ensure that they collect the results properly. If they don't do that, the other groups will not have anything to work from, and then the whole way we work will not work. So we make sure that they are prepared, and they do these flow sheets, mandatory for each group, and they show it to the teacher, and we check for understanding, lab safety. And here's an example for a group of students that they like to make it electronically, but it's not a demand. They can do it by hand as well. But they have to write down all the steps in the exercises they're doing. Here is another example that looks a little bit more complicated. Here we can see that they have 3 samples illustrated by 3 sheets up here, and they do a lot to make this nice, because it's mandatory. Before we made it mandatory, it really was not very helpful what they did. So approval is important. Then it's very important that they exchange the results between the groups. It's very frustrating if they're not able to deliver some results that other people can understand. So each group are responsible for obtaining the correct results for the groups, and we do a lot to tell them that. And all groups need to distribute the results to other groups, and all groups they received results. So it's kind of they need to take this serious. And they can help themselves by making data sheets that they give to the entire class, so they are sure that they will get the right results for their presentation. And they can upload this information on the campus net, the network we have, and they can also communicate to each other by this net. And this is an example of how some students have made a table here that they want their student colleagues to fill in their results, so they're sure to get the right things for their presentation. Another example here from another group, they want some other information about the background. Then we also have these laboratory journals. And why is that important? Because if they just fill out the sheets for their colleagues, it should be okay. But we want them to be generally aware about data handling, that it's important. So it helps the whole process, and also gain some understanding about what is important to write down and what is not important. The first time we introduced it, they said, but why should we do that? We just write the results, and it says in the protocol what we have to do, so we don't need to write down anything. So we have helped them understand some more about this project with the journals, and then we also think that it's important, because if they didn't have to do that, they would not be aware of their own subtopic. They will only be aware of their own subtopic, and they have to also learn about the others. So again, approval is important. Here is an example of what we say they have to be sure of: raw data, deviations from protocol, conclusions, remarks, and things like that. Here's an example. They have to do this presentation in the end, the poster presentation, and they have 20 minutes. Each group, they are about 3 to 4 people, and it's in front of the class. It's an examination, and everybody has to speak, and they will get feedback in front of the class. And the advantage is that they like to hear each other's feedback. They think they learn from each other in that way. They find it challenging, and they are positively surprised about this, because they are very critical in the start, saying, oh, isn't it a little bit embarrassing that we have to get feedback in front of the class and so on. And then they feel that we take them seriously, and that's also important. The disadvantage is that some get very nervous, but as I wrote here, they have survived everybody until now. And it takes time, of course, to have this huge a day on it, and it can be difficult because they are in groups to have their individual, to know the individual's contributions. And this is an example where you can see how they present a poster. The results of the course evaluation, I will take this very quickly. We have here, before we implemented the CDIO concepts, they were also very happy about the course. And we have some that are not very happy in between in the spring. And usually in the spring we have a large group, whereas we have a smaller group in the autumn. Also the students in the spring come more directly from the high school, whereas the ones in the ones in the autumn, they have done something else, so they might be a little bit more mature and prepared for such a way of teaching. We can see here how they are doing at the written exams. It seems like they do a little bit better in the beginning, but it's also because this year they are third semester students, most of them, whereas we changed until second semester. So, but else the way we measure, we have this course evaluation does not reflect the CDIO concept very well. That's also a part of it. We don't think we can measure directly a significant impact of what we have done. So, yeah. And then some comments say that this is from a student project work, went very well and was fun, good experience to present the poster. And then we have one that is a little bit more frustrated. More effort should be done in the journals and introducing of equipment. We have tried to improve that part. The project, even though interesting, it was diffused, but then he wrote in the end, he think it was okay that they sometimes were in deep water. And again here reflects that this sharing of results can be confusing if it does not work well. I think I have went over the most of it. You can read more in the paper. But in general, they find it interesting, the students, and during this project period, we think they improved their understanding of lab work, and they work more engaged than we have seen earlier. Yeah. So in conclusion, we think it's a very suitable for introducing this concept at second semester, but it's optimal for about 20 to 30 students. We have used it with more students, but it's best with that number. And we did not have any significant measurable impact, but we think that synergy and coherence was improved. And we think more effort should be done in collaborating CDIO learning concepts into the evaluation at the university. Okay, and you can go and see the full program in this presentation in the freestyle session.
Okay, thank you.